there, I'm Ayazaki Calantes, and I will guide you now on a historic exploration to discover the impressive timeline of matter knowledge along with atomic theory. Our knowledge of atomic domains has developed through multiple centuries, from medieval philosophical concepts toward modern scientific understanding which form the basis of our existing world. The scientific discoveries represent more than mere breakthroughs because this tale demonstrates human curiosity combined with creativity and knowledge-seeking endeavors. This presentation shows important breakthroughs in atomic theory alongside their transformative effects on technology, alongside industrial advancements and contemporary daily routines. Let's begin with the ancient Greeks. Around 400 BCE, philosopher Democritus proposed one of the first ideas about atoms. In 400 BCE, philosopher Democritus brought forward his concept about atomic composition. During his time, Democritus introduced the atomos. the atomos theory, which proposed that the universe contained uncuttable particles called atomos. His unproven atomic theories established the foundational rules that every subsequent model of atomic theory built upon. Future atomic research drew inspiration from his theories for many generations of scientists. Fast forward to the early 1800s. When a revolution in atomic theory began to unfold, John Dalton, an English scientist, built upon Democritus' ideas. In 1803, Dalton proposed his atomic theory, which stated that all matter is made of atoms, that atoms of the same element are identical, and that chemical reactions involve the rearrangement of these atoms. This was groundbreaking, providing a clear and systematic explanation of matter at the microscopic level. Now, let's jump to the early 1900s. When things started getting even more interesting, this was the age of quantum theory. When scientists like J.J. Thomson, Ernest Rutherford, and Niels Bohr made remarkable discoveries. J.J. Thomson's discovery of the electron in 1897 revealed that atoms were not indivisible, as Dalton had suggested, but contained smaller subatomic particles. Then, in 1911, Rutherford's gold foil experiment showed that atoms have a dense, positively charged nucleus at their center, and electrons orbit this nucleus. This understanding opened the door to modern atomic models, as we now understand atoms to be made of protons, neutrons, and electrons. Later, in the 20th century, Niels Bohr refined Rutherford's model by suggesting that electrons orbit the nucleus in fixed energy levels. And with the development of quantum mechanics by scientists like Schrödinger and Heisenberg, we move even closer to the sophisticated understanding of atoms we have today. In fact, today's atomic theory integrates quantum mechanics, showing that electrons exist in probability clouds, not fixed orbits, and that particles can behave both like waves and particles. The beauty of science lies in its ever-evolving nature, as we have journeyed from the early ideas of indivisible particles to the complex quantum models of today. We've seen the interconnectedness of discoveries. Each breakthrough built on the last, leading us to a deeper understanding of the universe. These atomic discoveries are more than just theoretical. They've paved the way for incredible technological advances. Think about the devices we use every day. Smartphones, computers, medical technologies, all of these rely on our understanding of atomic structures and quantum mechanics. Our ability to manipulate atoms and molecules has also opened up revolutionary fields like nanotechnology and medicine, when we are designing molecules and materials at an atomic scale. The potential is endless, and it all started with a simple curiosity about the nature of matter and the fundamental building blocks of everything around us. As we wrap up our journey through the history of atomic theory, we see how far we've come, from ancient theories to the groundbreaking work of modern scientists. The history of atoms is a story of human curiosity, exploration, and perseverance in understanding the world at its most fundamental level. And remember, this is just the beginning. Who knows what future discoveries awaits us in the world of quantum physics and atomic science? My hope is that this exploration inspires you to keep asking questions, stay curious, and embrace the beauty of science. After all, every great discovery started with someone wondering what if. Thank you for watching and never stop exploring.